Hey everyone, and thank you for coming to another Node.js Enterprise Tech conversation with Mike Samuel at Google. Mike, do you want to introduce yourself?
Yeah, I work on Google's ISC hardening team. So hardening is part of security engineering. We take frameworks, libraries, and programming languages and try to make it, improve them to make it easier to produce secure and robust software. So it's a fairly small team of security specialists, all of us software engineers, who support a much larger group of application developers.
Awesome. And I'm Tierney Cyren. I'm a developer advocate at NodeSource and chair of the Node.js community committee. So let's dig into your team and what that team does a bit more. What is that? What's the scope of security, and how does that kind of play into what you do day to day?
So we're responsible for addressing kind of at a framework level common classes of vulnerabilities. So we want to take the burden off application developers. For example, if every application developer has to scrutinize all their code to make sure they don't have an XSS, that's not an efficient use of their time. Whereas if we can improve a framework so that they would have to make unusual kinds of errors to be vulnerable to XSS, then we've improved developer productivity a lot and improved the security for the end users. Yeah.
Awesome. I think that kind of plays a bit nicely into the next topic, which as a developer who has to go and do that stuff, has to go and do that work. What are the kinds of questions that someone who isn't a developer, like a project manager, should be asking their architects and devs about security?
So a team that has a story for how to address each kind of common security vulnerability is going to be a lot better in a lot better place than a team that doesn't. So for example, a team that can say, we are safe from XSS because we use contextually auto-escaping template languages. And what that means is that, when we produce HTML, our template language understands HTML and makes sure things are escaped. So we use those tools consistently. So we're going to be safe against XSS. And maybe we have another story for why we're safe against SQL injection. Having those stories, kind of, thinking through how do we avoid each of these problems in a systematic and consistent way, puts you in a lot better place.
Awesome.
Other kinds of problems, a team that pays attention to their dependencies and updates their dependencies when security problems are found upstream is going to be in a lot better place.
Yeah.
So a lot has been written about the large number of dependencies that many node projects have, and that's not a problem in and of itself. It's just that when a bug in one of those becomes known, attackers might move quickly to exploit it. So having a story for how you stay up to date is good.
So you mentioned, having a path for or an answer for the common security vulnerabilities, or common routes of attack. What about uncommon ones? I'm curious if that's kind of something that PMs should be asked. If there's a question, PMs should be asking their team members about that.
Well, so yeah, of course there can be, depending on the nature of the service you're providing, there might be security vulnerabilities that are specific to that. And starting security reviews often early and consulting with security specialists to understand kind of, can relate your project specifics to attacks that have happened in the past is definitely useful.
Awesome.
And then engaging with security specialists who keep an eye on kind of emerging threats is important too.
So you also mentioned, managing dependencies. And, this is something I've kind of learned a lot about recently, in terms of like, a vulnerability usually isn't going to be at the top level, especially in a dependency tree, like specific to Node. It's going to be, 3 or 4 modules deep in a dependency of a dependency of a dependency. How do you suggest people kind of manage that or deal with that? Or, what kind of tooling do you suggest maybe?
Yeah, this is actually one of the things that I've been working with TC39, the JavaScript committee, and I've been putting out some code, and my goal is to make it possible to give different levels of trust to different modules. So, for example, shell access is, if you can access child process, then you can, if an attacker can get a string to child process, then they can do all kinds of bad things.
Yeah.
Very few of your dependencies actually explicitly want to use child process. Very few of them need to use child process to do their jobs. So you can focus your attention on understanding the dependencies that do need it if you can make sure that only a small number of modules can access that at runtime. And this is an example of, kind of within Google, we use static analysis a lot. Static analysis might let us know that a C++ binary, for example, where it is calling out to, spawn a shell. In Node, because it's JavaScript, static analysis only gets you so far. So you need to do kind of dynamic enforcement. And so I've been doing a lot of work on coming up with mechanisms that let us say, hey, I know based on kind of running my tests that these modules need to invoke child process. I'm going to focus my attention on making sure that they're doing it well. And then I'm going to make sure that in production, no other modules try to invoke child process. And that kind of limits the downside. And so kind of, being able to say, like there's these different sources of authority that can be abused, being able to differentiate the few of your many dependencies that need any one of those lets you kind of limit the downside and focus your attention on and do kind of focused reviews.
So that actually brings up a super interesting for me, because or super interesting thing. So one of the attack vectors with a Node module is the package JSON in a post install script. I'm curious because that's not really first party JavaScript. It's more third party. So I'm curious how that could or does or theoretically would integrate into this kind of story, if there is integration at that level at all.
So yes, I think somebody, I forget the researcher's name, but showed that it was possible in principle to come up with a worm that ran at post install time and used the fact that someone might be kind of npm logged in to make edits to the package.json and propagate itself. And so you do something post-install basically invokes bash. That bash could then patch the package.json in your project root and then npm commit it. So if, one solution, definitely always use second factor authentication with npm. I talk about that a little bit in the, I should mention, I put out this, I and some colleagues from Google put out this document called NodeSec roadmap.fyi. And a security roadmap kind of explains where we are security-wise and how to get to a better place. And this abuse of post-install scripts is documented there. Ideally, you run it in a sandbox. So there are npm flags that allow you to skip post-install scripts. And you want to separate the privilege to modify stuff under node modules, which is kind of the end goal of most post-install scripts. from the privilege to change developer code, modify the local Git client, and also separate it from the privilege to commit to the global NPM repository. So I've documented there one way to do that involves keeping a local snapshot of NPM and offloading the running of post-install scripts. It's not trivially implementable in a few lines of bash, so I think it's something that would be provided as a service, kind of bundling all that into a nice, easily deployed set of tools. But the short answer is two-factor authentication in the short term, and try to use those tools when they become available in the long term. And one of the nice things about maintaining a local snapshot is it actually allows you to react in a more agile manner to security incidents. So if you find that somebody has figured out how to exploit a third-party dependency, you might not want to wait for upstream to fix that. You might say, hey, some people have come up with a fix. We'll patch our local copy because maybe we only use some of the functionality it provides. So we could cut out whatever is exploitable if we're not actually using it, push to our local repository and not have to wait for upstream to secure our servers against the 0-day.
That's super awesome. That's a very interesting approach, and I'm kind of excited to see us continue to evolve to that space. A lot of the things you've kind of said kind of speak to the next topic that we were discussing, or we were going to discuss, which is, there's a bunch of different things that developers and frameworks can do, and it's always kind of jumbled, at least to me. I'm curious, what are the problems around security that devs expect the frameworks to solve?
That's an excellent question. The previous thing reminded me of one more thing on kind of what should project managers be asking, and that just very briefly is a team that has a story for what to do when things go wrong is going to be in a better place. So a team that is thought through kind of where are our database backups? Can whoever is holding the pager, if the pager goes off at midnight, do they know how to restore a known good version of the application from backup? And do they know, if it happens to be a relatively new member of the team, do they know how to contact someone who can provide a second pair of eyes?
Yeah, totally. And honestly, that actually kind of goes into my thought process around the question of, what security problems can devs expect frameworks to solve, in that, one subset of frameworks is local caching. And, that is one of the things that I personally have seen not enough individuals and companies doing. And that kind of answers that question of, okay, we have a local cache, here's where the thing I need is. And so that also kind of goes to, this is a framework to solve this problem, although I don't necessarily know if that's how we're talking about framework in the sense that, what security problems should that solve?
I think, so for example, some application containers provide when you push a new version of your application, they provide caches of the old versions, and so you can revert back to an old version if you have problems with the new version. Is that kind of what you were talking about?
Yeah. So I'm thinking of something like either JFrog Artifactory or Verdaccio, which is a Node app that's just a local NPM cache. And so JFrog or Artifactory is a paid product, but it's an enterprise grade cache basically. Yeah. And so that's kind of what I'm thinking about in that term of like a framework providing a level of security. It's not really a security feature, but it's more of a okay, how do we go fix something when there is an issue that we can't solve ourselves? And so like it's a weird kind of gray area, but I think it goes to solve that that point that you were talking about.
Yeah, and I think considering that kind of framework code is fine. I think you're right that there are certain kinds of problems that we can expect to solve in a framework like Express, and there's certain problems that might be addressable in something like Artifactory.
Yeah,
and I think Artifactory would definitely be relevant to kind of the where might be a place to offload running a post-install script so that we can separate them from developer privileges.
Yep. And so, you mentioned Express. What are the things that Express should be solving? Like, what are the security issues at that level that should be solved?
So I'm horribly ignorant of how Express is used. My understanding of Express is that it is a grab bag of many different features, and many different product teams use kind of different subsets of those features. That said, I think you can address many, frameworks can give you a place to kind of check a security assumption, and they can also make it very easy to consistently use good tools. So I think Express bundles with a set of file type handlers, and that's one place that you can kind of check security assumptions. They also allow you to bundle template languages. So, for example, if the simplest, easiest thing is to use a contextually auto-escaping template language, then you can really get a handle on XSS. One other way to address many security problems is to represent the safeness against safeness of some value that you're going to ship over the wire as a value, as having a particular runtime type. And so frameworks like Express can be a way to, can provide a place to check that assumption consistently. So, for example, I may express in the type system the distinction between a string, a plain old string, and a string of HTML that I know is safe to load into our origin. Maybe safe HTML is just the name of a type that wraps a string. And we do this throughout half a dozen programming languages and frameworks within Google. So I define a type that encapsulates some security property. Safe HTML is safe to load into a DOM in my company's origin. Express can then change the writer so that if you are opting into this additional security assumption, it will reject arbitrary strings that are written to your response body, when the content type is HTML, but it will allow and unpack these values. And then it could integrate template systems as known producers of safe HTML values to kind of make this transparent to the user, where they're, when they use the tools that it provides. They may also bundle an HTML sanitizer that is another known kind of trusted producer of these safe HTML values. So if you represent kind of as an object, if you represent your security assumptions kind of in your type system, the framework can check those assumptions where they need to be checked. And the framework, by bundling tools, can make it very easy for developers to produce values, to distinguish strings that may come from an attacker from values that have gone through a process that is known to produce safe outputs. I think I repeated myself and was mumbling a bit there.
You're good. Yeah. So, a lot of, one of the things I kind of picked up on in that is that it seems like having an extensible system is kind of important for this. And that is a lot of what Node.js has done. Like a lot of the Node stuff is extensible. You build on other people's work. You hook into things, and Express very much does that. I'd actually like to call out one specific thing just for people who are listening, is Helmut. Helmut is a super good tool for Express, and I think Happy as well, that does a lot of this stuff by default. And so it kind of goes beyond like Express as a tool should be doing this, but then actually goes into, hey, we're doing all these things that Express doesn't do, which outside of Express in that specific ecosystem, I think it's a very valuable thing for people who are interested in security and care about it to actually go look for tools that explicitly go and do these things that the core library or core framework doesn't do. Do you have any thoughts or feelings on that?
Well, I think Helmut, I think, does a good job, among other things, of security relevant headers, making sure that your HTTP response has kind of the headers that you need. So I think, since, the web started, people have noticed that, hey, there's these kind of common problems that we could address, but we can't just change the way browsers work. And so we'll add a header and allow people to opt into, kind of the same behavior. X content type options is one of those. And Helmut allows you to kind of makes it easy to make sure you're not missing a lot of those opting into same behavior things, and generating things like content security policies to lock down eval and client-side JavaScript and that kind of stuff.
They do a good job with a lot of that things. They also do a few interesting edge cases. I can't think of them off the top of my head. I've written a few articles about it, but I can't think of it off the top of my head. That said, I am curious. Is that kind of a abstraction of the responsibility to someone else? Because that stuff should theoretically be included in Express. Is it good that someone took the time to kind of go build that stuff where they recognize its weaknesses, or should that kind of be something that's included in Express, or whatever? And Express and Helmut are one example here. There's multiple examples of things like this, but that kind of approach of going and fixing things.
I haven't talked to the Express maintainers about this, but my understanding is that the Express, they have a large deployed base of clients. So kind of changing the bytes that are sent over the wire is going to be very hard. But I think but frameworks, Express could Express. It's very much a plugin model, and so kind of providing a kind of core set of plugins that do things like some of what Helmut does with, I don't know the breadth of what Helmut does, but some of what Helmut does around things like response headers, being able to say, hey, this is my security posture in a list of well-known plugins, and then making sure that any departures from, kind of like, I have these plugins which provide known good tools, make it easy for my development team. I want my development team to use them consistently, and I want to, have a small white list of exceptions to those rules. That, supporting that model, I think, is something that Express could do.
Awesome.
And again, my horrible ignorance of kind of the breadth of what the Express team is doing, they may already have made great strides in that area. I don't know.
I'm also not as familiar there as I should be.
I really need to learn about it.
It's okay. Definitely a lot of stuff happening there constantly. So, we've kind of talked a bit about what problems frameworks should solve. What about problems that are not on the framework's shoulders. Is that something you have strong feelings about, or any thoughts around?
For Node frameworks, almost all of the client-side JavaScript is not on their shoulders. I think some frameworks do try to do code motion from the server to the client, and so they may stand in a place to also vet and maybe rewrite client-side code to do dynamic enforcement. A lot of the network level attacks are things that are best addressed at the container level, kind of your Google Cloud or the Amazon equivalent. So a lot of network level attacks are kind of best addressed at the container level. I was
going to say, when you say container, do you mean like Docker or whatever kind of container in quotes replacement, or do you mean even like any kind of server, like VPS or whatever metal you're deploying to?
So
the distinction there.
Yeah. So a system is a group of kind of cooperating machines, and containers provide a way to introduce those machines to one another. So I may have a number of servers, they talk to a number of database backends, and maybe there's some microservices in there as well. And so the container is where you might handle all the kind of exchange of secret strings that allow and say, hey, you're a server, this is where to go for your database access. Here's where these services are. And so it provides a lot of that. If you can attack a system by trying to get to talk to a different database backend or trying to intercept that traffic. And so the container can do a lot to make sure that all those are encrypted. Sometimes you want all ideally you check, you authorize access at every single level. So your microservices don't just trust a message because it happened to come from your web front end. So your web front end, when it sends a message to a microservice or to your framework, it carries some credentials that say, I'm doing this on behalf of a particular user. And each step in the chain reauthorizes. And so kind of threading those end user credentials through this distributed system is, that can be, that can involve both the framework and the container, because the container is often the one that kind of generates secrets for each node in that distributed system, or maybe for each process running on a node in that distributed system. And this is getting kind of into Istio and that kind of stuff, which that's not my specialty.
Yeah, same. So on that, one of the things that I kind of wonder about pretty often is what are some of the more emerging things that happen, in terms of devs and needing to plan for security, because security is kind of ever evolving. How do people recognize what's happening now? And then also, how do they, you can recognize what's happening now. How do they plan to recognize what's happening in the future as well?
There are a number of emerging threats right now. So new browser features can provide, new sources of threats. So, for example, there are now custom elements in browsers. And there was a paper called the Script Gadgets paper who showed how features like HTML import and some ways that new frameworks like Polymer and React use to register element definitions. I think React doesn't actually register element definitions, but I think there, the HTML import, some of the HTML import stuff made it through React. How these new features can let you work around, bypass content security policies and other mechanisms that you use to control how code loads on the client. So there's that. If you happen to be doing, blockchains are the new thing, there is an emerging body of security literature on ways not to do blockchains, and kind of how common application errors can lead to problems in block, so that you're attesting to things that you ought not be attesting to. I think another of the kind of big changes in security, it used to be the case that security fuzzers, you could run a security fuzzer and it would point you at some possible weak places in your application code. And attackers started running security fuzzers. So they would automatically generate a bunch of queries to see, hey, this site may be using an old version of some kind of content management system, which is known vulnerable. Fuzzers are now being built around constraint solving systems. So there's likely to be a bit more of an arms race between the security testers and attackers, because constraint solving systems are heuristics. So just because I happen to, my constraint solving system might find 9 out of 10 vulnerabilities. The attacker's constraint solving system finds 9 out of 10 vulnerabilities, but they're not the same 9, you've got a problem. And I think you also asked about how do you deal with emerging threats.
Yep.
Ideally, you'd have a security specialist who reads through the literature and keeps you apprised and filters them to see what's relevant, what's not. I think there's some good tooling in this area. So NPM audit, for example, does, it's a great feature that kind of tells you when your dependencies have known problems. Not all security vulnerabilities make it into the source of truth for NPM audit, but it's great for cases where those are actually published. If you're not a security specialist, you just need to kind of know someone like me who reads the HTML specification so you don't have to.
Awesome. So yeah, I have a lot of things to ask about that, but I'm going to hold those off for now. Moving on to our last thing, our last topic, I'd like to ask kind of what new features, in JavaScript at a platform level, at a framework level, at an application level, could or would help teams actually manage security for dev or production deployments?
So given that that many Node applications, the code that I write as an application developer is just the tip of the iceberg, and there's this huge amount of third-party dependency code that I depend upon. I think one of the critical things is ways to, as I said before, trust code to do what it trust just the modules that need a particular source of usable authority with access to that. So only the things that really need child process get access to it. And so being able to say these modules need it and and I assume the rest don't, requires us to have some concept of module identity. And so I proposed to the TC39, the committee that maintains the language, a particular concept of module identity. I think that in JavaScript is a very dynamic language, and so static analyzers like TypeScript's type system, like ESLint, like Google's Closure compiler are great, but they have to make optimistic assumptions. So representing security assumptions about values in the runtime type system, I think, is important. So I'm a big fan of contract types, and I published the NodeSec patterns package to serve as a basis for that. And then I think we need a way to lock down powers that, features that are rarely used and which are known to be problems. So, eval is evil. But as long as one of your dependencies really, really needs it, then you have to turn it on for the entire runtime. And that is unfortunate. Eval has legitimate uses in kind of, loading that dynamically generated code. But again, like differential authority for modules should not just extend to other modules. It should also extend to kind of built-ins like eval.
Awesome. And so with that, I think we should wrap up. But before we do, are there any links you'd like to, direct people to? Any places, anything people should look at? Specifically, like if that proposal for the identifiers in JS at TC39, if that's up, that would be awesome. Anything else?
Yeah, a lot of that. I gave a talk at JSConf in Berlin. I think that should be up on YouTube soon. So the JSConf, it's an awesome conference, and they put all of their talks up. I also had some aspirations of being a YouTube star, so I put together a YouTube series on showing a series of web puzzles. So if you like security puzzles, you can check it out. If you go to medium.com/@MikeSamuel, MikeSamuel, you should find it, and it's just called Puzzling Towards Security. And that's where I don't publish often, but that's where I publish kind of my thoughts on how to coordinate, make interactions between security teams and application developers more efficient and productive.
Awesome. Well, thanks for joining us on the Enterprise Tech Conversations, Mike. Really appreciate it.
Thanks much. It was lovely questions.
Awesome. Thanks.